Hello everyone, welcome to our channel Boring Physics. Today our topic is center of gravity. Center of gravity. Very important topic for class 10 icse. So what is center of gravity? We can say that at a point or a center of a body where the entire weight of the body can be considered to act at that point. That is called basically the center of gravity. So how we can explain it? Let's see first. Suppose we are having a body. We are taking a body. So a whole body, it should be consisting of so many particles, small particles. So suppose here so many particles are there. So each particles have a weight, right? Suppose one particle, two particle, three, four, five, six, seven, eight, nine, like this. One particle, the weight is W1, one is W2, one is W3, one is W4, W5, W6, W7, W8, W9. So here n number of particles are there. So Wn. Now the question, see all the weights are one type of force due to gravity and all are parallel to each other. So these all parallel forces acting in the same direction, that is the downward direction. And in this body there is one point we have to take, which one is called, means whole weight, it should be replaced by only one point, that is called G, or you can say that the center of gravity, where the total weight of the body, total weight is suppose W. So what is this W is nothing but W equal to, we can say, W1 plus W2 plus W3 plus dot dot, means all the particles weight, it should be act at this point. So total W is this one. So in this point, what about the algebraic sum of the moments due to the weights W1, W2, W3, W4, W5? What about the entire of each particle about this point G should become 0? So what we can say, the point, the point at which the algebraic sum of moments of weights of all particles constituting the body is 0. So means at the first line I told, the entire weight of the body can be considered to act at this point G, that is called the center of gravity. So here some examples I'm giving. They can ask also, generally the question can come, what is center of gravity, or some regular uniform objects they can ask where the center of gravity can stay, or the position of the center of gravity. Like suppose if we say some examples, number one, Suppose we can say circular ring. Circular ring. What about the center of gravity? Center. Center of the ring. Center of ring. Suppose if I say circular disc. Circular disc. Geometric center. Geometric center. Solid sphere is the common example I'm telling you. Solid sphere, that is also geometric center. Geometric center. Suppose if we say for a rod, a metal rod. In case of rod, it should be the midpoint of the rod. Okay, that will be the midpoint of rod. Midpoint of the rod. Number five, we can say solid cylinder. Solid cylinder. Solid cylinder, it should be the midpoint on the axis of the cylinder. That will be the midpoint on the axis of the cylinder. On the axis of the cylinder. This one can be. Suppose another one important one they can give, the triangular lamina. Triangular lamina, important one. More or less they can give this one. Point of intersection of the medium. The point of intersection of the medians. Okay, so these are the topics, these are the examples you can go through. It can come in the exam. Okay, and the numericals, not like that type of numericals they'll give from here. Now we need to know how to calculate the center of gravity of an irregular lamina. How to determine center of gravity of an irregular lamina. In this case, what do we have to take? Suppose one irregular lamina we have to take. Suppose we are taking a irregular lamina. Okay, this irregular lamina, the center of gravity we have to calculate. We are making three holes on this lamina. Suppose here one, here another one, here is another one. So three hole we have made it. Three holes, suppose we are giving the name P, Q and R. Okay, and all are the near the edge of the lamina. Now, if we suspend this lamina with a plumb line from the hole P on a nail or on a pin, you can say, which one clamped horizontally on a stand. Now you have to check that the lamina, it should be free to oscillate about that point. Now, when it is freely rotate, when the lamina has come to the rest, draw a straight line from the P2 along PQR already we have taken. So suppose we are taking that along this way, PS. Same way, if we repeat these things, suppose now that the nail point, if we keep it at Q and then again free to oscillate, then another one point we'll get from Q to, suppose the point is T. Same way from R we can see another one point if we get, sorry, in this way, suppose U. Now we can see all that, all the three lines, they are meeting at this point. So this point is known as G, is the center of gravity. So here this G is called center of gravity. So this way we can easily calculate the center of gravity of an irregular lamina. Okay, next topic we are having motion. Motion, at the first part we have done one, that is the translational motion and the rotational motion. Now another one type of motion we have to do, that is the uniform and non-uniform circular motion. Okay, this one basically known as the circular motion. Two types of, we have to introduce that. Let's see, we are going to start now. Uniform circular motion. Let's see, uniform circular motion. What is the uniform circular motion? First of all, we need to know about the circular motion. We know that, suppose if any body moves in a circular path, we can say that that is known as the body is in circular motion. Now the question, when a particle or any body moves with a constant speed, when a body moves with a constant speed, with a constant speed in a circular path, in a circular path, this or its motion is called uniform circular motion. Uniform circular motion. But in this case, one thing we have to keep it in our mind. In this circular motion or uniform circular motion, when the body travels equal distance through a circular path in equal interval of time. So means we can say the speed of the particle is uniform, but its direction will be changed. Suppose if we say when the body is in this way, this position, body can move along this way, right? So at each point, the direction of motion of the particle it can change. Suppose in this point A, suppose in this point B, it should be in this direction. This. In this point, it should be along this direction. In this point, it should be along this direction. CD. So, what about this continuous change in the direction of motion? It indicates that the velocity of the particle, the velocity of the particle, of the particle is non-uniform, non-uniform. But the speed of the particle is uniform. Okay, keep it in your mind these things. Very, very important topic, that the uniform circular motion. So another one thing also, if the velocity of the particle is non-uniform and the speed is uniform, we can easily say it should be the motion, circular motion, it should be accelerated. In the same way, if we say uniform linear motion, the speed and velocity are constant. And obviously, if both are constant, the acceleration should become zero. Keep it in your mind. But uniform circular motion, velocity is variable, means it should be an accelerated motion. Keep it in your mind this thing, important topic. So the next topic which one we are having, that is called centripetal and centrifugal force. So the topic is centripetal, centripetal and centrifugal force. What is it? Centrifugal force. First we are writing about centripetal force. Right side we are doing that the centripetal, left side we will do centrifugal. Centrifugal. Okay. What is centripetal force? We know that whenever any body is moving in a circular path, each and every point it is changing its direction. Right? We have seen that the four positions, suppose here A, here is B, here is C, here is D. So in this position, direction of motion in this way, C this way, D in this direction, right? So whenever a particle or a body moving in a circular path, it always changing its direction of motion at each point of its path. I'm just showing over here that the 4 points, other points also it will change its position, direction of motion. And it cannot be done without a force. The motion in a circular path is possible only under a force which is termed as centripetal force, which force is always acting towards the center of the body. Means in this point, center of the force in this direction, here in this way, here in this way, here is in this way. So means what we can say, What is centripetal force? If we want to say once, the force acting on the body moving in a circular path, moving in a circular path in a direction towards the center of circular path, towards the center of circular path, that is called centripetal force. So one thing, always keep it in your mind: centripetal force always acting towards the center. Okay, next we are going to discuss about centrifugal force. Let's see what is centrifugal force. Centrifugal force means a force. Which one we have done in the centripetal force, that is acting towards the center. In case of centrifugal force, if we discuss, it will be acting outward direction. So what we can say, if any body is moving in this direction, so in this point already we know that one direction of motion in this way, and the center, towards the center, the force it should be applicable, right? In this way force should be applicable. Here also force is inside, that is the centripetal force. And in this point always body tends to move in the outward direction. Okay, always body tends to move in the outward direction. This outward direction away from the center of the circular path, this is called basically the centrifugal force. But this force always acting opposite to the direction of centripetal force, and its magnitude should be same as the centripetal force. So what we can say, that what is the centrifugal force? A force, we can say a force can be acting on the body, can be acting on a body in the direction away from the away from the center of a circular path, center of a circular path. That one is known as the centrifugal force. But this way, the centrifugal force, it is not a real force. You can say that it is not a real force. This one is known as a fictitious force. It is known as fictitious force. Fictitious. Fictitious force. The force which is involved is the force of tension in the string or any body. So this way, so many example we can say for the centripetal force or centrifugal force. In case of centripetal force, you can say when a planet moves around the sun in a circular path. So in a circular path, sun is in the center, So the gravitational force of attraction on the planet by the sun, it will provides the centripetal force. And in the same way, in case of the centrifugal force, you can say that if we tied a ball at the end of a string moving in a circular path on a merry-go-round, on that time we can see one person who can stand on the merry-go-round, he will see every time ball is in rest. But any one person who is standing outside the merry-go-round, he will see that ball is in motion also with respect to the different person. So this one is an example of centrifugal force. You can thing, always keep it in your mind that centripetal force is always acting towards the center of the body, and centrifugal force is always outward direction. Outward direction. But its direction should be opposite to the direction of centripetal force. Keep it in your mind, opposite to the direction of centripetal force. Its magnitude is the same as of the centripetal force. If centrifugal force is greater, then if any body or any object it moving in the circular path, it can't move. It will move away from the circular path. And if the centripetal force is more, then it will slips. The body will slips. So when they can move in a circular path, when the both forces can balance each other, then only it can be possible. So these are the topics we are having in the first chapter of class 10, force icse force, class 10 force chapter. We are having up till this much. The third part I'll keep it for the numericals. If you have any doubt, any question, you can ask. You can write in the comment box. I'll give you the answer. Subscribe our channel. Thank you everyone.